Good day, viewers. You are welcome. Can you solve this type of integration? We call it Frulani type integral. The integral from 0 to 1 x raised to the power of n minus 1 divided by ln x dx, where n is greater than 0. Here is the step-by-step solution guide to the problem. Solution. By rewriting out the problem, integral from 0 to 1 x raised to the power n minus 1 over ln x dx. We said let I of n, make n as a function, equals to integral 0 to 1 x raised to the power n minus 1 over ln x dx. Since n is a parameter, differentiate with respect to n. Then we have I prime of n equals to integral 0 to 1, the partial derivative d dn, open bracket, x raised to the power n minus 1 over ln x dx. And the partial derivative d dn x raised to the power of n will be equals to x raised to the power n ln x. Then I prime of n will be equals to integral 0 to 1 x raised to the power n ln x over ln x dx, which is equals to, ln x will cancel out ln x here. Then we have integral 0 to 1 x raised to the power n dx. Now evaluate this simple integral. Then we have I prime of n equals to x raised to the power n plus 1 over n plus 1. We are evaluating this simple integral, introducing the limit 0 to 1, and this will be equals to 1 over n plus 1, which means that I prime of n equals to 1 over n plus 1. If I prime of n is equals to this, integrate with respect to n. How do we integrate this with respect to n? If you integrate I prime of n, this will be equals to I of n, which is equals to integral of 1 over n plus 1 dn. We are integrating with respect to n, which means that this will be equals to ln logarithm of n plus 1 plus c. But don't forget, from the question, they are given that n is greater than 0. Now, to find the constant, put n equals to 0. Put n equals to 0. From the function, we now have I of 0 will be equals to integral 0 to 1 x, this is raised to the power of n, and we said we are putting our n to be 0 minus 1 over ln x dx. I of 0 will now be equals to integral 0 to 1. X raised to the power 0, that is 1 minus 1 over ln x dx. So this one will result to 0. 1 minus 1, 0 value x dx. So if this is equal to 0, then from the solution, I of n equals to ln n plus 1 plus c. We said I of n is equals to 0. 0 will be equals to the logarithm of setting n to be 0, 0 plus 1, close the bracket, plus c. 0 will be equals to the logarithm of 1 plus c. And logarithm of 1 is 0. The 0 plus c will give c. Therefore, c equals to 0. Therefore, the general solution to this integral is 0 to 1 x raised to the power n minus 1 over ln x dx will be equals to, since c is equals to 0, then we have the logarithm of n plus 1. Don't forget that this is true when n is greater than 0, and this will be our final answer. Don't forget to subscribe to my channel. See you in the next video.